0009 है. So higher byte would be given stored as 00. Then again write for decrement stack pointer by 1 7FFE and program counter lower byte giving 09. Is it right? And then what? Now what?
Program counter assigned.
Now this should happen now. Program counter assigned to WZ. Why now? Because if it is happening here, then 0009 will be lost. So 0009 is stored first, then program counter assigned to WZ. It means what? Next cycle of code fetch, program counter will give what? 9000. Whatever may be there, that will go to instruction register. Right? This will continue as a subroutine. Right? This will continue as a subroutine. And then what? Then so all things like opcode fetch, program counter giving 9000 something goes to IR, all this will continue till program counter giving opcode fetch, program counter giving 9010, and at that point we have C9 going to instruction register. What is C9? Return or pop PC. So as it is pop, it is 1 byte instruction. Return or pop PC. How many machine cycles it will take? 3 more. Total 2 more. Why? Because it is expected to read the external memory for which stack point is going to give as an address and bring that value into program counter. So it would be a other read. Who will give address? Stack point. What is that? Stack pointer giving 7FFE. What is there? 09. And where this will go? Program counter lower byte. And increment stack pointer by 1. Use stack pointer to load and increment it by 1. So 9 will go to program counter lower byte. Other read. Stack pointer giving 7FFF. Stack pointer incremented. So again it is restored 8000. And 00 going to program counter higher byte. And then opcode fetch, program counter giving 0009 YY, and it will continue. Right? So what we have done, that I will come back, I will come here. So from 0006 it has branched at 9000, and from 9000 then 9010 it has came back at 0. Is it clear? This is subroutine. Is it right? Is it okay? Now there is small problem. So subroutine we have written for multiplication of H and L, and result to be in H and L again. Which is next lecture? So this subroutine uses other registers also. Subroutine, that what is the difference? That master and servant. Master is doing some calculation, tells servant that do this and give me the value back. And he gives the value. The difference is that servant is a different person. So something in his mind doesn't disturb with my mind. But here main program uses subroutine but that is executed on the same processor. So what my subroutine is doing? My subroutine of multiplying H and L, and result is stored back in H and L, but the subroutine is using other registers A, E, D, and one counter B. So B, A, E and D, these 4 registers are being used by my subroutine. So if before going for calling the subroutine, I am having some application in which these registers are also meaningful. So what subroutine does? Subroutine multiplies HL, gives me the HL. So if that is the only thing which I know, then register A, register B I am using for some purpose. I go call 9000, it returns back. HL is containing the result what I want. But if I say that yes, B was I am using for some purpose, after the subroutine if I again start using B, the B has been changed, right? So subroutine means the difference between master servant and this subroutine is that subroutine gets executed on same processor. So it also uses the some processor's registers. So what my subroutine is designed for? My subroutine is designed for multiplying H and L and storing result into HL. So I call subroutine with operands in HL and I get the subroutine returns the multiplication in HL. So what naturally I expect that other register, what you are doing, the other register should not be changed. But I can't write the subroutine then. I can't write the subroutine by keeping other registers intact. मग आता काय करायला लागेल? In the subroutine, it should not be changed, but I want to use them. So subroutine, I want that this answer must emerge from you. The subroutine, what is expected to be reflected in the result? Only HL. So HL should be source and HL is the destination. So subroutine is just like a mul instruction. Multiply H and L, result back to HL. So only HL should be changed and all other registers should not be changed. But if that is the condition, then I can't write subroutine because I want to use the registers. मग आता काय करायला लागेल? मराठीत सांगतो. HL मध्ये डेटा देतो, HL मध्ये रिझल्ट मिळतो मला. इतर रजिस्टर बदलायला नाही पाहिजे, ते आहे तसेच पाहिजे. म्हणजे मी कॉल 9000 केल्यानंतर आणि रिटर्न बॅक झाल्यानंतर बाकीचे रजिस्टर आहे तसे राहिले पाहिजे. मग बाकीचे रजिस्टर आहे तसे राहिले पाहिजे म्हणजे मला सबरूटीन वापरताच येणार नाहीत. मग जर का मला बाकीचे रजिस्टर वापरता येणार नसतील तर मी सबरूटीन प्रोग्राम लिहू शकणार नाही. सो व्हॉट आय वॉन्ट, the multiplication subroutine is supplied with the operands in HL, it returns back result in HL. Other registers should not be changed. But with this strict condition of not changing other registers, I can't write the multiplication program. So what I will do, I will take care that I will change but I will restore. What care I will take? At the end, they should be same what they were at the beginning. So subroutine, at the end of the subroutine, all registers other than HL should be restored back if I want to use them. So what I will do, at 9000, what I can do, at 9000, when I start the program, before starting actual program, before starting actual multiplication, I will store only 3 HL I will store because HL I want to change. B, C, D and equivalent flags, AF flags. So what I will do, I will push them. How? Push, say B, then at 9001, push D at 9002, push PSW, then from 9003 actually my program will be there, and when my program is over at say 9013 my program is over, then what I will do, I will pop it. I will pop, what should be? Pop B, pop D, pop PSW. I am pushing on the top and popping this reverse sequence. So pop PSW, pop D, pop B, and return. So what this will do? This will restore back my environment. This will restore back my environment. We'll continue. On Thursday I will try to for some session.